Hello students, welcome to all of you, and today we are start discussions of the lecture number 2 of the topic number 13, the electromagnetic waves and communication systems. In the previous lectures we are start to discussing what is the electromagnetic waves and some scientists name which can be help to give a theory of the electromagnetic waves. Then in these lectures we are discuss the source of electromagnetic waves and the directions of the propagations of electromagnetic waves and the directions of the producing the magnetic field, directions of the producing of the electric field also. The electromagnetic waves, when they are propagated, they produce the electric as well as magnetic field. Then in these lectures we are discussed all of these, and I will promise you in the previous lectures we are useful the Maxwell equations. Maxwell equations is equations of some scientists will be combined each others. काही सायंटिस्टना कंबाईन करून एक मॅक्सवेलने स्वतःचं काही इक्वेशन तयार केलं, त्यांना मॅक्सवेल इक्वेशन्स असं म्हटलं जातं. आणि त्या इक्वेशन्स जे काही इलेक्ट्रिक फील्ड आणि मॅग्नेटिक फील्डचं जे काही कनेक्शन्स आहे, जे काही रिलेशन्स आहे ते दाखवायचं काम करतं. लेट्स बिगिन. द सोर्स ऑफ EM waves. EM waves is known as electromagnetic waves. I said that when a waves will be passing through the mediums, then the accelerations of the charge which can be radiate the electromagnetic wave, they shows the propagations of the electromagnetic waves. This is the theory of Maxwell. According to the Maxwell theory, according to Maxwell theory, this is James Clerk Maxwell. According to the Maxwell theory, the accelerated charges radiates of electromagnetic waves. Accelerated charges radiates EM wave, that is electromagnetic waves. I will be used in the same topics, that is short form EM for the electromagnetic. Consider one of the charges will be oscillated with some frequency, and when they are oscillated or vibrated of the charges or particles in the mediums, then they are producing the electric field in a space, and they are also produce the magnetic field. Let's start to begin it. Consider a charges which can be oscillate with some frequency. Charge oscillating with some frequency, and this frequency is produced, and these charges will be produced, these oscillating charges, these oscillating charges will be produce the electric field as well as magnetic field. Electric field, that is E bar in space, and magnetic field, that is use B bar, also produce the magnetic field, which in turns is a source of oscillating electric field, which in turns source of electric field. Then I will be drawn one of the graph here when we are just discuss after the discussion of theoretical parts of the source of electromagnetic waves. Consider, according to the Maxwell theory, accelerated charges radiates electromagnetic waves. When the charges will be accelerate, then magnetic waves will be produced or radiations of the magnetic waves, electromagnetic waves. Then electric and thus the varying of electric field and magnetic field, varying of electric field as well as magnetic field regenerate to each other. They are regenerate to each other. Regenerate to each other. Then waves that are caused by the accelerations of the charged particles, and it consists of the electric field and magnetic field vibrating in a sinusoidally. Then consider waves that will be caused, waves that are caused, wave कशामुळे तयार होते, acceleration of the charge particles, and it consists of electric and magnetic field. Accelerations of the charge particles, and it consists also electric as well as magnetic field vibrating sinusoidally at a right angle to each other, and the directions of the propagations is called as electromagnetic waves. Wave that are caused by waves that are caused by reasons of producing of caused by accelerations of charged particles accelerations of the charged particles, then it consists magnetic and electric field vibrating sinusoidally in right angle triangles, in a right angle or perpendicular to right angles is called right angle, and gives the directions of right angle to each other or right angle, and the directions of propagations are, and directions of propagations is EM waves or radiations of EM waves. When you don't understand about the sentence, that is a wave that are caused by the accelerations of the charged particles, and it consists of the electric and magnetic field are perpendicular to each other, and directions of the gives the propagation and the directions of that propagations of the charged particles, this is called as electromagnetic waves or radiations of electromagnetic waves. Then I will be drawn one of the diagram here for the proper understanding what are the electromagnetic waves and what is the directions of the propagations of electromagnetic waves. And this is the z-axis, I will be drawn here horizontally, and this is the x-axis or maybe y-axis, and another one, remaining one is drawn here, this is y-axis, and it consists, the electric field is vibrating along the x-axis, and these three axes are perpendicular to each other. Then when the electric field are produced in the directions of x-axis, magnetic field are produced the perpendicular, this is the right angled, perpendicular to each other, magnetic will be produced the right angle and perpendiculars. Then the magnetic field is perpendicular to each other, then they are produced the another direction of another axis, that is y axis. Magnetic field is another axis, that is y axis. Then the propagation is also perpendicular, directions is also perpendicular to these two, and this is called as, this is along the z axis. These are three axes are perpendicular to each other, and three fields, one of the electric and magnetic fields are following the x and y axis, or xy, this is the yz and xz planes. Then another one is along to z axis. Let's draw here. Now I will be drawn the electric field. And this is the x-axis, and this is called as Ex, and that is the electric field. I will be drawn here for the electric field. They are sinusoidal, and now I will be drawn the magnetic field, and the magnetic field is in the perpendicular to this axis. This is like here. The all fields, electric fields and magnetic fields, are perpendicular to each other, and I will be drawn for a cross line. They are like they are perpendicular to each other. Then the directions of the propagations, that is by, this is the Ex, electric field along x-axis, magnetic field along y-axis. Then the propagations of the electric field, or directions of the electromagnetic wave, is along z-axis. This is the shows how to electromagnetic waves are produced. This is the main source of the electromagnetic waves. According to the Maxwell theory, accelerated charges radiates electromagnetic waves. Accelerated charges will be produced the magnetic as well as electric field in the space, and the magnetic and electric field are perpendicular to each other. They are also perpendicular to the directions of propagations of electromagnetic wave. This is all about the formations or source of the electromagnetic waves, that is EM waves. Now we are just revise the Maxwell equations. You know the Maxwell equations, and you are studying the Maxwell equations in a previous lectures or the topic of electrostatics, but you call in a different names. That is one another names, that is called as maybe Gauss laws of electrostatic, Gauss law of magnetism here. Then let's write Maxwell equation. Then Maxwell equation number 1. These are mainly 4 Maxwell equations, and for the field, that is for the mediums, and for the space they are for the vacuum, there are more 4 equations here. Then the electric field E dot ds is equal to Q divided by epsilon 0. This is one of the Maxwell equations, but this equations is also known as Gauss equation, Gauss law of electrostatics, Gauss law of electrostatics. Then the Maxwell equation number 2, this is the Gauss law for electrostatic, and I will be write the Gauss law for the magnetism. ds is equal to 0. This is the Gauss law for the magnetism, and also called as the Maxwell second equations. The Maxwell will be combining two or more equations. They are produced the third equations, and this equation is called as Faraday's Lange's laws. The third equations I will be write here. These are both are Gauss law for electrostatics and Gauss law for the magnetism. Then they are shows the relationship between the electric field as well as magnetic field. Then the additions or summations or the combinations of two laws, that is Faraday's laws as well as Lange's laws, gives the third Maxwell equations, that is here. This is the third Maxwell equations, and last and end Maxwell equations are there. One is a electric field, another is magnetic field. One is another number first. They are produced alternately. First is electric, another is magnetic, and another electric, and first electric, second magnetic, third electric, and fourth is always magnetic field. Then B bar dl, and one is along the surface and one is along the length. Then they gives mu 0 I plus mu 0 I plus, they are gives the relation, that is epsilon 0 mu 0 into d phi by dt, that is d phi by dt, but this is the electric flux, this is the magnetic flux, and this is the electric flux. The one law for the electric field, another one is magnetic, one is electric, and another one is magnetic. One is for a surface, another for a length of conductor. This is the surface, and this is all about the Maxwell equations. Let's end of this lectures here.